problems involving simple machine. A lever, and mind you, a lever is an example of a simple machine. We have first class lever, second class lever, third class, we have the first order, second order, third order of lever. Okay, so the question is talking about lever. A lever is used to overcome a load of 50 Newton by applying an effort of 10 Newton. The question says we should calculate or find the mechanical advantage of the lever. The mechanical advantage MA is equal to the ratio of load to efforts. Just to remind you, mechanical advantage is equal to load over efforts. And if you look at the question, we are given the value of load L to be equal to 50 Newton. And at the same time, we are given the value of efforts to be equal to 10 Newton. Okay? We are to calculate the mechanical advantage. Straight away, mechanical advantage will be equal to load, which is 50 Newton, divided by the effort, which is 10 Newton. Newton cancel Newton, then 50 divided by 10, we are having 5. And that is the simple solution to question number 1. 5 is the value of mechanical advantage. Question number 2. For question number 2, the efficiency of a machine is 70%. Calculate the work done using this machine to raise a load of 10 kg to a vertical height of 2 meters. Take the value of your G to be equal to 10 meters per second square, and that is year 2015, number 8. Let's consider the simple solution to that question. To calculate the efficiency of this machine, in this case, we are going to have the work output over the work inputs times 100%. Efficiency will be equal to work output divided by work inputs times 100. What is work output? The work output is the work done by the machine itself in performing the work. The work done by the machine itself is the work output. The work input is the efforts. The person that applied the force, that performed the work on the machine, is the work input. Okay? The question now says the efficiency of a machine is 70%. We should calculate the work done using this machine. Work done using this machine, that is the work input by the person. The work done by the person is the work input. The work output is the work done by the machine itself is the work. So let's see the simple approach to this question. We are going to have the work output will be equal to mgh, the mass of the body, acceleration to gravity, and the height covered, divided by the work input times 100%. And let's have the value given to us. We have the value of the mass is 10 times 10. Then the height cover is 2 divided by work output, work input divided by work inputs. Everything will be equal to the efficiency, and the efficiency is 100%. But in this case, the question says the efficiency is 70%. We are going to take the percent of 70. So everything will be equal to this. So let's try and work it out. 10 times 10 is 100. 100 times 2, that's 200. Divided by work inputs times 70 divided by 100. From there, let's make work inputs a subject of the formula. Then we are going to have 200 times 100 all divided by 70. We are going to have 20,000 divided by 70. We are going to have 285.71, and that is the work input. Okay, and that is the work done by the person that used this machine, and that's what we mean by work inputs. And if you look at the question says we should try and calculate the work done using this machine. That is, the work done by the person that used this machine is this 285.71 joule. And that's the simple solution to question number 2. Question number 3. A machine whose efficiency is 75% is used to lift a load of 1000 Newton. Calculate the effort put into the machine. If it has a velocity ratio of 4, in this case, I gave to you the efficiency to be equal to work output of our work inputs times 100%. We have another formula for efficiency depending on how the examiner or the questionnaire asks the question. Okay? Efficiency in this case will be equal to mechanical advantage over velocity ratio times 100%. Remember that mechanical advantage is load over efforts. And if you look at the question has given us the value of load, which is 1000 Newton. Okay, let's put it there. Mechanical advantage 1000 over E, which is your efforts. Let's put this one into this equation. The efficiency will now become efficiency will now be equal to mechanical advantage, which is load over effort, and for MA we have this. So instead of having mechanical advantage, we are going to put this one instead of this. It's going to be 100 divided by E. Then we also have divided by, divided by for this, divided by velocity ratio. And if you look at that question, the velocity ratio is given as 4. Instead of having V here, 4 over 1 times 100%. Okay? So that the efficiency now will now be equal to 100 over effort times, I want to change this division to multiplication, and once I try to do that, the denominator will move up, numerator will move down. It's going to be 1 over 4. Okay? Let's try, this is 100 times 1, that's 100. Then we have E times 4, that's 4E. But we have been given a particular value for efficiency. For efficiency, we have 75%. So instead of I don't need to write times 100% again. Because we have been given a particular value for the efficiency, which is 75%. 75 out of 100. 75 divided by 100. Try to cross multiply. We are going to have 75 times 4E will be equal to 10 times 100. So in this case, we are going to multiply 75 by 4. That is 300E will be equal to 10 times 100 will give us 1000. So that our E will be equal to 1000 divided by 300. Our effort now will now be equal to, we have 10 divided by 3. And if you are trying to divide this one, you are going to have 3.33333. Well, let's stop it like that. Effort is a force in Newton. Effort is a force. You put 3.33 Newton. And that is what we are told. That is a simple solution to that question. Question number 4. What efforts will a machine of efficiency 90% apply to lift a load of 180 Newton if its effort arm is twice as long as its load arm? We are given the efficiency of the machine to be 90%. So we are still coming to efficiency to be equal to mechanical advantage over velocity ratio, that's 100%. In this case, mechanical advantage is load over effort. Our velocity ratio, let's take it as x over y, because we define mechanical velocity ratio as distance moved